The heavy shutters of the megafactory slowly rise, revealing a sterile environment bathed in cold blue LED lights as the facility pulses with technological life. Project Maglev X-1 is initialized. Within Sector 7 of this next-generation smart factory, the journey of crafting the world's most advanced transportation system begins today. Central control systems awaken, processing millions of lines of code as holographic interfaces map out the intricate blueprints of a machine built to defy gravity. Autonomous vehicles navigate the floor with surgical precision, delivering the raw materials of the future specialized alloys designed for extreme strength and minimal weight distribution. Every movement is synchronized by a master artificial intelligence, ensuring that the components for the Maglev's chassis arrive exactly when and where they are needed. The air hums with the sound of electric motors and climate control systems, setting the stage for a symphony of high-tech construction and mechanical mastery. With the initialization complete, the factory transitions into active production mode, where the boundary between science fiction and modern engineering begins to blur significantly. Our focus shifts to the heart of the machine, the sector where the superconducting magnetic core will be forged through unmatched precision and extreme cooling techniques. At the core of the Maglev lies the superconducting magnet. Robotic arms wind niobium titanium filaments, thinner than a human hair, around the central steel housing. These coils are the conduits of immense power, requiring absolute uniformity to maintain the stable magnetic fields necessary for high-speed levitation and frictionless travel. Precision is measured in microns. Laser scanning systems inspect every millimeter of the coil, detecting deviations that the human eye could never hope to perceive. The tension is set to exactly 450 newtons. Status remains green as the alignment check confirms a deviation of less than 1 micrometer. The completed core is moved into the cryogenic phase, where it will be prepared to function in temperatures colder than the dark side of the moon. Liquid nitrogen is released, creating a thick, ethereal mist. This extreme cooling process is essential to achieve the state of superconductivity where electrical resistance vanishes. The magnetic levitation precision is targeted at 99.999%, a feat only possible through this rigorous and meticulously controlled thermal management. Inside the vat, the laws of physics are manipulated. The core becomes a powerhouse of energy, ready to lift tons of metal with silent, invisible force. Mechanical connectors are secured with satisfying clicks. Every joint is vacuum sealed to ensure that the cryogenic environment remains stable during the train's entire operation. Pressure levels stabilize within the chamber. The heart of the Maglev is now beating with pure electromagnetic energy, waiting to be integrated into the hull. The transition is complete. What was once a simple spool of wire is now a sophisticated engine of propulsion, the very soul of the X-1 project. Final finishing touches are applied to the housing. Even at this stage, the aesthetic of the machine reflects the precision engineering hidden deep within its structure. Rows of these powerful units are prepared, each one destined to play a vital role in the massive levitation array that will support the train's weight. Each core is serialized and logged into the master database, ensuring total traceability and quality control for every single component of this high-speed masterpiece. The cores are now ready for the next phase, the grand assembly. They move toward the central bay where the physical body of the Maglev takes shape. Welcome to the dance of the giants. Dual-arm robots operate with a level of coordination that mimics human grace, but with 1,000 times the strength. One arm holds the massive frame with unwavering stability, while the other prepares to execute the complex welding sequences required for structural integrity and safety. Non-contact laser welding technology is employed here. The high-frequency pulses create a bond stronger than the base metal itself, without ever touching the surface. The result is a seam as smooth as silk. This process ensures zero thermal distortion, maintaining the aerodynamic profile of the train with absolute fidelity to the design. Light dances across the factory walls as the laser carves through the metal. It is a symphony of sparks and light, a testament to modern manufacturing. The synchronization is flawless. Every movement is calculated to the millimeter, preventing any collision while maximizing the efficiency of the assembly process in real time. The tools are swapped automatically. The same robot that welded the joint now prepares to verify its own work using an integrated three-dimensional scanning system. A green laser grid envelops the structure. The system captures millions of data points every second, creating a digital twin to ensure the frame is perfect. Structural integrity is confirmed at 100%. The frame is ready to withstand the immense pressures of traveling at speeds beyond 600 kilometers per hour. Suspended by electromagnetic clamps, the chassis undergoes a full rotation. It is a skeletal masterpiece, waiting for its skin and its technological nervous system to be installed. While lasers handle the seams, high-torque pneumatic drivers secure the internal supports. The marriage of traditional mechanics and futuristic optics creates an unbreakable bond. The metallurgy is carefully monitored. Even the heat-affected zones are controlled to prevent any brittleness, ensuring the maglev remains flexible yet incredibly strong under stress. Underneath the main deck, specialized mounting brackets are installed. These will be the interface between the magnetic levitation units and the structural frame of the train. The dual arm dance concludes for this section. The frame moves forward, having been forged in the crucible of precision laser light and robotic coordination. Next, the maglev will receive its protective layer, a skin designed to slice through the air with the least possible resistance in high-speed environments. The skin of the X-1 is a composite of carbon fiber and aerospace-grade resins. Robotic sprayers apply a specialized electrostatic coating for a glass-like finish. This isn't just for aesthetics. The paint reduces skin friction, helping the train achieve an incredibly low drag coefficient of just 0.12. Reinforced glass windows are integrated into the hull. These panels are engineered to withstand the vacuum pressures of the testing tunnels without a single crack. Every seal is double-checked. In an environment where air pressure is manipulated, the integrity of the cabin's atmosphere is a top priority for passenger safety. Peripheral sensors are installed around the hull. These eyes of the train provide real-time data on air density, temperature, and any potential obstacles on the track. The aerodynamic shielding is now complete. The maglev looks less like a train and more like a high-speed projectile designed for the next century. Engineers utilize virtual reality to inspect the data bus synchronization. They can see the invisible flow of information through the train's digital nervous system. Kilometers of fiber optic cables are verified. The sync between the central AI and the individual levitation modules must be instantaneous to maintain high-speed stability. The curing cycle enters its fourth and final phase. The surface is buffed to a diamond-grade shine, ensuring that even dust particles cannot find a grip. Skin integrity check. Pass. The composite shell is both a protective shield and a high-tech interface, ready to face the stresses of near-vacuum travel. The hull meets the chassis in a final monumental union. The physical form of the Maglev X-1 is finally whole, standing as a marvel of engineering. Inside, the luxury of the future awaits. The cabin is a silent sanctuary, isolated from the incredible speeds and forces occurring just outside the carbon walls. The finishing touches are applied with reverence. Every detail, from the aerodynamic curves to the placement of the logo, reflects the pursuit of perfection. The Maglev X-1 stands ready. It is a masterpiece of design, a fusion of carbon, steel, and light, Waiting for its first breath of speed, it now moves toward the ultimate proving ground, the negative pressure tunnel, where it will attempt to break the barriers of traditional ground transportation. The tunnel seals. Huge vacuum pumps begin their work, sucking the air out to simulate a near-space environment, reducing drag to an absolute minimum. Power is surged into the guideway. The maglev rises, floating exactly 10 centimeters above the rail. The friction of the world has officially been left behind. A low-frequency hum vibrates through the air as the magnetic fields lock in. Stability is confirmed. The X-1 is now truly a vessel of the air. Acceleration begins. The propulsion system kicks in, pushing the train forward with a force that is as smooth as it is relentless and powerful. Speed indicators jump. In the control room, tension is high as the velocity climbs past 300 kilometers per hour, doubling the speed of conventional rail. The world outside the glass becomes a blur of light and shadow. The vacuum environment allows the train to accelerate without the roar of wind resistance. At 400 kilometers per hour, the air remaining in the tunnel is torn apart. The sound is a deep, resonant roar of pure kinetic energy. 500 kilometers per hour reached. The control laws remain perfectly integrated, adjusting the magnetic gap thousands of times per second to ensure a smooth ride. Thermal imaging confirms the system's efficiency. Even at these extreme velocities, the superconducting cores remain at their optimal, sub-zero operating temperatures without any stress. Inside, the stability is uncanny. A glass of water remains undisturbed, a testament to the perfect balance between the magnetic levitation and the aerodynamic hull. 620 kilometers per hour. Target reached. The Maglev X-1 is now one of the fastest moving objects ever created for land travel. Pressure drops to 0.1 atmospheres. The train slices through the near vacuum like a hot knife through butter, breaking the limits of traditional physics. Every hour of design, every micron of precision in the factory has led to this moment of absolute, unbridled performance and technological triumph. Deceleration begins. The energy is captured and fed back into the system, showcasing the sustainable and efficient nature of this next-generation transit technology. The test is a resounding success. Velocity 60-20 confirmed. Stability verified. The Maglev X-1 has proven it is ready for the real world. The X-1 emerges from the darkness of the tunnel into the light of the main hall, greeted by the people who brought it to life. The lights flash in a celebratory sequence. The machine seems to breathe. Its mission accomplished. Its potential now limitless for the future of humanity. 100 meters of engineering brilliance. The Maglev X-1 lies under the factory lights, a shimmering testament to what we can achieve through innovation. The engineers stand in awe of their creation. This was not just a project, it was a journey to redefine the very concept of distance and time. A masterpiece of engineering, a beacon of progress. The future is no longer a distant dream. It is here, and it is levitating above the rails. Control law integrity is verified. Project Maglev X-1 is officially ready for service. The journey from the factory to the world is about to begin. As the lights go down, the legacy of the X-1 is just starting. Thank you for joining us on this extraordinary journey into the future.